Hey everybody, welcome back to another round of engineering. And yeah, let's keep going. Short video for you today because I wanted to show you a couple of ways of using computers to find the inverse matrices. So from the last video, let's go ahead. I will write down my equation. So we had something like our coefficient matrix times our variable matrix is equal to that leftover stuff, if you will. And we are dealing with this situation where our coefficient matrix was -2, -3, 1. We had a 4, a -2, a 1. And then we had -1, -1, 1. So there is our coefficient matrix right here. Then we had our variables, which I was calling x1, x2, and then I called it y. And then lastly, we had this leftover stuff, 1, 0, and -2. Now, in the last video, we went through and we developed the technique for finding the inverse of the coefficient matrix. And again, that was by hand using our row operations. Now, you still need to know how to do that, but now I'm going to show you how you can use computers to do that faster. Okay. So let's go ahead here. I guess I should probably remind you what the inverse matrix looked like. So I'll go ahead and put that down as a review. And I'll go ahead and give you the solutions for x1, x2, and y so that we have those in our memory bank. So if you don't remember how we got these, you need to go back and watch the last video, and I will leave these in fractional form. Okay. Actually, what I'm going to do is just write down the numerators. So we'll go ahead and do that. -1, 6, -6, 1, and 16. So I've written down the numerators. And one cool thing about matrices is that if there's a common term for every single element, and I haven't gone over this, this is kind of a new thing that I'm just thinking of. If there is a common factor in every element, you can pull that common factor all the way out. So all of these things should be multiplied by 1 over 11. Okay. That's, again, you don't need to know that. That's just to make our lives easier for writing things down. Okay. Last thing, since I'm scrolling through my notes here to try to find the solution. I do not have it. Ah, shameful. Last thing, just to refresh our memories, at one point we found this graphically. We have also found it analytically. So I'll remind you that the solution to this system of equations is this. So x1 is 1 over 11, x2 is -17 over 11, and y is equal to -38 over 11. So there's the summary page. Let's go ahead now and I'll show you how to do this on the calculator. Now, the first one I'm going to do is a graphing calculator. I've managed to find an emulator for a TI-83 online, and so we'll start with that. So let's go ahead and shut that down. Get that out of the way. Okay. So what you have on the screen here is an emulator for a TI-83. Now, I understand that you might have slightly different calculators. I myself have a TI-82, and I'm sure that you might have an advanced one, that kind of thing. These should all roughly work the same way. Okay, so Texas Instrument is not in the business of changing the layouts on their calculators if it can be avoided. So let's go ahead and I will show you first of all how to use the TI-83 to find the inverse matrix. First of all, we have to figure out how to enter in a matrix on the calculator. And so where we find that is right here. So I'm highlighting it. I'll highlight it with my little thing. Boom. Okay. And you'll notice it says matrix in yellow. What that means is that I actually have to hit the second button, the secondary function button, and then select this matrix button. So I'll go ahead and do that. I'm going to hit second, and you notice that now on the screen you get the little up arrow that says that we're using the secondary function, and I'll hit matrix. And now we see that the TI-83 can actually store something like, looks like 10 matrices. Okay, we're only going to need 2, but if you ever want, you can store more than that. And let's go ahead and store our coefficient matrix as A. Now, this is just the names. We actually have to go over. We want to edit the matrix, so we're going to have to go over and choose edit. And again, I want to do matrix A. And so I'll go ahead and hit enter. The first thing that we're going to be asked to do is specify the number of rows and the number of columns. So from our last bit, we remember that our matrix A is a 3, and I'll hit enter here, by 3 matrix. I believe that the TI can do something like 9 by 9 or 10 by 10 matrices. So just bear that in mind. If you have more than something like 9 by 9, you should start thinking about the second method using Matlab. So I have a 3 by 3 matrix, and you notice that the screen, it changes according to what we have edited. So I'll go ahead and I'll type in our coefficient matrix. We have -2. Now be careful. You want to use the negative sign, not the subtraction sign. The TI-83 specifies those two as being different. So I better put a -2, and I'll go ahead and hit enter, and I'll put a -3, a 1, and I'll just keep going. Our coefficient matrix, as we started out the lecture with. Boom, and there we go. Check to verify that I've written everything in correctly. Looks good. Okay, now we want to exit out of this. So to exit out, I need to actually use the quit command. So I need to, again, go up here and hit second and then quit. You see the quit in the yellow here. So I hit second and quit. If we want to verify that matrix A is still properly stored, we can hit second matrix. And now instead of going to the edit, we see that we're looking at what has been stored in the TI-83's memory. So matrix A is now stored as a 3 by 3. If we go ahead and hit enter, that loads matrix A to our calculator. And if I hit enter again, it should display our matrix. Indeed, it looks like it has been stored properly. Now, the one place that I'll tell you to be careful, it is sometimes easy to confuse the letter variable A with the matrix A. So if you want a letter variable, you hit alpha. Notice now I have an A symbol, and then I'll hit this math button where the alpha gives me A. And notice the difference between the presentation of these two. For a matrix, the TI puts the square brackets around, whereas for just the simple variable letter A, it just gives no brackets. And of course, if I hit enter here, it'll yell at me. I haven't actually stored anything in the variable A. So just be aware of those two. So let's go ahead and clear. Now I'm interested, first of all, in finding the inverse of the matrix A. So let's go ahead. What you would normally think of. Let's select matrix A. And now I'm just going to say, find the inverse. So I need to find the inverse symbol. Okay. So that's the nice thing about the calculators. Once you feed the TI-83 a matrix and you use the same inverse symbol, it knows to do the proper thing. So I'll go ahead and hit enter, and you'll notice it will spit out a 3 by 3 matrix. Now there's two things to note here. First of all, the calculator spits out numeric values, decimals. The second thing is that you notice that it only shows the first column. The TI-83 and a lot of the TI lines are limited to 10 decimal points. Okay? So what happens is it's only displaying the first column because it's keeping 10 decimal points and it wants to display all of them. Notice the ... on the right side of the screen. So if I want to scroll over, I'll hit the right arrow. And now I can view the second column and the third column. So indeed, the TI has actually calculated the inverse matrix. It's just a little bit hard to see because of how it decided to present the decimals. Say you don't like that. There is a way to get it to force it to display fractions if it's actually possible. So I'll go ahead and show you that just because it helps make it a little easier sometimes. I'm going to hit this math button. No second. I actually want the math function. So I'll hit math. And you see the first option is frac. What this tells the TI to do is to display the answers as rational fractions if possible. So I'll go ahead. So sometimes you'll do this and it's not possible. It's some ugly, irrational number and you're host. You're just going to have to keep the decimal points. But at least here, I can hit enter. Okay, so it says take the answer from the previous calculation, that is the inverse of the coefficient matrix, and display it as a fraction. So a little bit of thinking, and now, aha, we see the fractional, the rational values that we had written on the PowerPoint. So yay, we have now found the inverse of the matrix using the TI-83. Let's go ahead and find the solution to the problem. In other words, the x1, the x2, and the y values. Well, that's going to require us to enter in a second matrix. So that matrix B. So I will again hit second and go into the matrix menu. I'm going to go over to edit. And now I don't want to overwrite A. I want to keep the coefficient matrix. So I'll go down to matrix B as in boy. Now what size of matrix is this again? Yeah, 3 by 1. So let's go with 3, enter by 1, enter. Okay. And we'll go ahead, 1, 0, and -2. So now I have my coefficient matrix and I have the leftover GAC matrix. I can't remember what we call that. So, okay, leftover GAC matrix. I'll go ahead and quit out of this, quit. And now let's go ahead and solve for x1, x2, and y. Okay, I'll let you think about what we're going to do. Got it? Okay, so I'll take my matrix A, I will take an inverse, and then I will multiply it by matrix B, as in boy. Okay. Now again, the TI is smart enough to recognize that it's dealing with matrices, and it will perform the matrix multiplication in the proper manner, so long as you have the correct sizes. In other words, the columns of A match the rows of B. So if you ever do this and you get an error statement, there's a couple of things to look for. The first one is to make sure the columns of A match the rows of B. And the second one is to make sure that you entered in the values properly. Okay, so let's go ahead and we'll hit enter. Oh, I don't like that. Fraction or decimals. Let's go ahead and get fractional values. Hey, those look familiar. Those are the x1, x2, and x or y that we found earlier by hand. It's just now we could have done it on the calculator. Pretty cool, huh? You don't seem impressed. I'm trying to make your life easier. Let me show you a different trick. Okay. So say that you just didn't care about the matrix, the inverse of the matrix. You just wanted the final answer in one go. There is a second way to do this, which I was completely unfamiliar with until I found this emulator and started digging around. So let me go ahead and show you that as well. Okay. And this other way is based on kind of smashing the coefficient matrix and that B matrix together. Okay. So just to give you a refresher, remember that when we have our coefficient matrix A, our matrix X and B, sometimes I write this as the coefficient matrix, and then I write in the leftover matrix, something like this. So I guess I better be specific and write everything in. So I said, oh yeah, sometimes you just take out that vector, the variable matrix, and you write it like this. And this just helps us keep track of things when we're doing stuff like Gaussian elimination. Your TI calculator is smart enough to understand this format. Okay, and so there's a command that we can do on the TI-83 that if we feed it this form of the matrix, it will automatically do everything for us. So let me go ahead and show you that. So again, I've got my calculator. Let's go ahead and I will define a brand new matrix. I'll store this one as C as in cat. Okay. And now I want to kind of put in that whole smashed together matrix. So it still has 3 rows, but now it will have 4 columns, 3 columns for the coefficient matrix, and then that last column for the B matrix. So we'll call it 3 by 4. And let's go ahead. We'll put in the coefficient matrix, -2, -3, 1, and now that value, the B matrix value, 1. So I don't have the ability of drawing that vertical line in, but you can kind of imagine it being there. So we have 4, we have -2, we have 1 and 0. And lastly, -1, -1, 1, and 2. So I've put in the coefficient matrix and that B matrix kind of smashed together here. Let's go ahead and back out. And now I'll show you the magic command. So usually you could do inverse of A multiplied by B and the answer pops out. There's a second command that we can do here that'll just do that all in one go. So I've entered again the matrix menu, and now I'm going to go over to math. Now I won't talk about the rest of these. If you're interested in knowing what determinant, det, or the T that stands for transpose, I'll let you find that out in either linear algebra or Phys 345. Where I'm going to go is down here to what's RREF. Now I have to even look up, I don't know what RREF stands for. Boom, fly out bubble. Okay, but I know that this is the command I need. So RREF, and let's feed it matrix C. Enter. I'll close the bracket. And now what we'll see is that the output will be the identity matrix and then our actual values. Oops, not store, excuse me. I'm going to have this output as fractions just to remind us. Okay. So I'll go ahead and hit enter. And you'll see now that it has produced a 3 by 3 matrix. And then we have our answers. Our answers don't look right. Let's make sure we haven't dropped a negative sign somewhere. Oh yes, I'm sure that Greg has done something wrong. Let's take a look-see here. -2, -3, 1, 1. Okay. 4, -2, 1, and 0. Good. -1, -1, 1, and -2. I'll leave that in there. Okay. This is why it's always good to double check yourself. Okay. So I'm not going to cut that out. Greg makes mistakes. You're fully aware of that. This happens. Okay. But it's because we've done all of that other work that we know that this was wrong. Okay. So let's go ahead and go into the matrix math menu again. We're going to go all the way down to RREF. We're going to stick in matrix C as in cat, and I'll tell it to output as fractions. So this kind of tells the calculator, do all of the Gaussian elimination. So it has the one, it's done the ones on the diagonal, and it's actually zeroed out the columns above and below. And so we have our final answer. And hey, that looks familiar. All right, that's the answer that we found by hand and, graphically. And hey, that's cool. So the calculator can do the work for you. So that's all I have to say about the TI. You say, well, what happens if I need something more beefy, something more powerful? Oh, I'm glad you asked. Okay, that's where we go to this bad boy, Matlab. And I know that all of you have access to Matlab. Just a refresher, or at least to remind you. Again, how do we actually define matrices in Matlab? Well, first off, let's give it a variable name. I'll call it A. We use the assignment operator. In other words, we take the variable and we want to set it equal to something. Okay. So we assign it a value. And now how we specify matrices in Matlab is that we start with a square bracket. And what we'll do is we'll write values going across the first row, the elements being separated by a comma. So again, if I want to write the coefficient matrix, -2, comma, so next element, -3, next element 1. Now I'm done with writing the top row. How do I go to the next row? Matlab separates rows using a semicolon. So I'm going to go ahead and put a semicolon in here. That tells Matlab, okay, row number 2. So let's go ahead for -2, 1. Third row, -1, -1, 1. Now I'm done. Go ahead and close the bracket. Notice that it highlighted to remind you, okay, it's closed. And now we simply want to tell Matlab to store our coefficient matrix. Notice there's nothing in the workspace. Once I hit enter, it spits the matrix out so you can visually check to make sure that you've written it in correctly. And on top of that, we now have a workspace variable called A, our coefficient matrix. Let's go ahead and let's store matrix B. Think about what you'll write here. You got it? Good. Okay, one column. So I put in my element. I need to move to the next row. Put in my element, move to the next row, and close it off. So we should see 3 rows, 1 column. Ah, okay. Good. And it visually displays that for us. So the last piece of magic here, we need to do the inverse. And just like you would expect, we have a couple of different ways of doing it. We could do something like A raised to the -1 power. Matlab is smart enough to recognize that as being the inverse when given a matrix. And you'll notice that here it just truncates to 4 digits. Or, for example, I believe there's an inverse A command, and you can do the exact same thing. So it doesn't matter if you do A raised to the -1, Matlab is smart enough to interpret that as an inverse when you feed it a matrix, just like the TI-83. Or if you prefer, inverse A, and it will do the same thing. Lastly, what we want is we want the inverse of A times B. Ta-da! Again, it's smart enough to understand what the matrix multiplication is, and so it goes ahead and does it. Boom, no problem. Now, I'm sure there's a way to actually get it to output a fraction. Let's say we want it to be a fraction that we might recognize. Matlab has a command for that. It's called RATS. Okay. Essentially rational, if you will. Okay. So what this does is it tries to find the closest rational fraction to the decimal that you've presented. So if we do something like rats, the inverse of A times B, this should output fractional values. 1/11, negative 17/11, negative 38/11. Cool. Let's go ahead and do it for the inverse matrix while we're at it, just to make sure that everything looks okay. And voila. Pretty nice, huh? So there's 3 different ways that you can use a computer to find the inverse matrix and solutions to a system of equations. Okay? 2 different ways on the calculator, the TI-83 in particular, but that should extend to 86s or 82s, the general graphing calculators, and a second way using Matlab. Bear in mind, Matlab's a little bit more robust. It can do larger and larger matrices at the cost of a little bit of computation time. Okay. That being said, you're still responsible for knowing how to do this by hand. Okay? I can't emphasize that enough. You need to know what the computer is doing, and that means you need to know the basic row operations. Okay? You are not absolved from that. But that being said, once you feel confident and familiar with how to do these calculations by hand, you can always verify or double check using Matlab, using the TI-83. And as we progress further on the course, you can rely more and more heavily on Matlab to do the nitty-gritty matrix stuff if you want. Okay? Unless specified, at some point I'll say, okay, you can use Matlab. Do it by hand right now. Keep practicing. Hey, short video just to give you a heads up on that. Thanks for your attention. I'll see you next time.